Very good morning, my dear students. Now we'll continue the chapter called Motion in One Dimension. In this, we are dealing with the last topic, which is motion under gravity. In the motion under gravity, first we had discussed about freely falling body. Then we had already discussed about a vertically projected a body. Now, individually we have discussed. Let us combine these two cases and discuss in this session. Right? Freely falling and vertically projected. Right? Let's combine these two. And what are the models required for the NEET exam and the other competitive exams? Let's see. And before that, I just wanted to give you three important cases from the previous discussion. Not based on the today's topic. Right? First thing, the first case. So simple, three cases. The first case. This is the ground, a body which is projected vertically with an initial velocity u. You know it will reach to the maximum height. When it reaches to the maximum height, h maximum, what is the final velocity at this point? The final velocity at this point is 0 meters per second. Initial velocity will have some value. As the body is moving up, the initial velocity reduces and finally becomes 0. Now the question is, at half of the maximum height, imagine this is the half of the maximum height. What is the velocity at this point? That's a question. And I had already given you as a note, at half of the maximum height at this point, right? The final velocity at half of the maximum height is u by root 2. So this is what we are going to derive now. So what we are going to derive? This one. So we are going to derive this expression. Alright? Let's derive it. It's so simple. They are talking about maximum height and half of the maximum height, and given value is u. Okay. See, we are going to find the final velocity at that particular point in terms of initial velocity. And we have a maximum height expression. What is the maximum height expression in terms of initial velocity? U square by 2g. And this we had derived by using the formula v square minus u square is equal to 2gh. G value is negative because the body is moving up. Okay. From this we have derived actually this expression. I'm not going to derive it now. Okay. We have already done it. Now, carefully look at the situation. Let us apply the similar formula for this half. Okay. Similar formula for this half. What is the final velocity at this point? V square minus initial velocity is u square is equal to 2 into, right, minus g into h. What is this h here? This h is h maximum by 2. Understand? So that is h maximum divided by 2, my dear students. Right? So this 2 cancel. So v square minus u square is equal to minus g into h maximum. What is h maximum value? So that's u square by 2g. H maximum, this is not half of the h maximum. Half is cancelled here. H maximum is u square by 2g. So 1g cancel here. It's so simple derivation, my dear students. And have a look at here. So v square is equal to, what is left in the right hand side? Minus u square by 2, and already minus u square is here, so just take this minus u square to the other side, it will be plus u square. So now from here you can take common u square, 1 is left here, plus minus u square is already taken common, minus 1 by 2. What is that? 1 minus 1 by 2 is 1 by 2. So v square is u square by 2. From here v is equal to, just apply square root on both sides, u by root 2 meters per second, my dear students. See here. Is it easy? Is this easy? I'm asking everybody, is this easy? In the last class, we have not discussed the derivation. So this is the derivation for that. Alright. Now, there's a class work I'm going to give you now. So this is the class work. Right now, you need to send me the derivation, what I'm going to ask you now. Same here. It's a ground. A body is thrown up with some initial velocity u. It will reach to the maximum height after some time, that we know. After traveling 3 by 4 of maximum height, okay, after traveling 3 by 4 of maximum height, at this point we need to find the final velocity. So at this point final velocity is 0, right? After traveling 3 by 4 of maximum height, find the final velocity. Don't miss it, right? So if you solve in the same way, you will get the final velocity at this point is equal to u by 2 meters per second, my dear students. This is already we discussed the expression. So this expression we discussed in the last class, but derivation you have to do it now. How to do that derivation I have shown you here. Alright. So do not try to by heart the things here. Try to understand the concept, and this is the way of solving some questions also. These are the methods will be useful in solving some questions. Right? Now, another. Let's have a look at the another important. This is the first important case, and let's have a look at the second important case. Second important case is also so simple. This is the similar vertically projected case. As I've told you, we are going to mix the freely falling and the vertically projected case. Commonly asked question it is, have a look at here. There is a body which is projected up with some initial velocity u. It moves up, final velocity will be 0 at maximum height, that you know, right? So there is some distance traveled by this body in the last second, yes or no? So this is what? The distance traveled by the body in the last second, imagine. So this I am writing it as last second. Distance traveled by the body in the last second. So after reaching to the maximum height, final velocity will be 0 and the body will free fall now in the return journey. So this is the distance traveled by the body in first second. Okay. So what I am going to write here, the interesting thing I am going to write here. Imagine the distance traveled by the body in the last second is 5 meter. So definitely distance traveled by the body in the first second also it will be 5 meter. Remember, distance traveled by the body in the last second in upward motion is equal to distance traveled by the body in the first second in downward motion. Alright? And the most important thing I'll tell you, listen carefully here. Distance traveled by the body, any body in the first second, it's easy to find out in downward motion. This is the upward motion and this is the downward motion. So how simple it is to find distance traveled by the body in the first second of its downward motion. In the downward motion, right? So we have the formula distance traveled, S is equal to ut plus half gt square. So where g is positive only in the downward motion. So S is equal to, in a downward motion means initial velocity of the body is 0, half into g into in first second, right? So in first second, from here to here, time taken is 1 second. So it's 1 square. So your answer is g by 2. Remember, whatever may be the freely falling case, distance traveled in first second is equal to g by 2. Okay, clear? So distance traveled in the last second will be equal to distance traveled in the first second. Obviously, distance traveled in the last second also will be the same, right? Clear? So that's it. This is another important case. Now, let's see the third case, my dear students. Third case. Here, already we have the formula for the maximum height is u squared by 2g. What is u? Initial velocity. H maximum is from here to here. Now, let's combine these two once again here also. Freely falling and vertically projected. So that means you have your time of flight which is equal to 2u by g. Did you remember that? Time of ascent is t suffix a u by g. Time of descent is also u by g. Time of ascent plus time of descent is equal to time of flight. Did you remember this one? Time of ascent plus time of descent is equal to time of flight. Now my question here is identify the relation. Identify the relation between h and t. What is h? A maximum height. And what is t? Time of flight. Right? So my question here is identify the relation between h and t. So simple. H maximum is equal to u square by 2g. So from this, let's find out u. What is u? It's gt by 2. U square by 2g. 1 by 2g into u square. What is u square? G square t square by 4. See the simple expression we are going to find. See, we have this relation. The question is find the relation between h and t. So this h will be as it is and this u can be replaced with t. U can be written in terms of t. So that's why I have taken this equation. Alright? So h maximum is equal to 1g, g cancel here. Its a numerator is gt square by denominator is 8. So this is the very important expression which will be useful for you in the next chapters even, right? Try to remember this. This is a very important expression. So these are the three important cases and the commonly asked questions and applications. Try to identify and practice. And let's continue the session. Let's continue the session and let's learn some more applications. Right? Number one. See number one. This is the most commonly asked question. The first application, what we are doing. There is a ball which is thrown up with some initial velocity u. Look at here. And it is thrown up in this way. It goes to some height and comes back in this way. Carefully see. It comes back in this way. Actually, it goes straight and comes back in the same path. For your better understanding, I had drawn in this way. Imagine at a common height, at a particular height h. Okay, at some height h, both the sides. Here also the same height, right? At a particular instant means at some height from the ground. Height means always we measure from the ground. At some particular height, in the upward journey, so that at this instant the time taken is t1. Carefully. Right? At this instant time taken is t1. At the same height, the time taken from here to here is t2, my dear students. Carefully. At some particular height, instant time are given. One is t1, another one is t2. At the same height. Alright? Now, in this case, the commonly asked question is find the expression for the initial velocity in terms of T1 and T2. Commonly asked question. Find the expression for the initial velocity in terms of T1 and T2. Okay? Are you ready? Let's solve. It's so simple. What is the expression for the time of flight actually? We have the time of flight expression, which is 2u by g. This is the time of flight expression. Now, carefully see. From here to here time is given t1, and from here to here time is given is t2. And what is the time taken from here to here? How much time it took to reach from here to here? The same time it will reach to move from the height to the ground. See, how much time it will take from here to here? Same amount of time will take from here to here. That's what we discussed in the last class. If the time is 10 seconds is taken from here to here to cover the same height in the downward motion, same 10 seconds it will take. So that means from here to here it takes t1 time. Alright? This is the simple logic here. Now, what is the total time taken by the body? Let's see. From here to here it is t2 is given, and from here to here it is t1. Again, from here to here it's already given t2, and remaining height it is covered in t1. So the total time taken here it is t1 plus t2 is equal to 2u by g, my dear students. From here you can find the u value, right? So it's so simple. So u is equal to the g into t1 plus t2 divided by 2. So this commonly will be written in this way, half into g into t1 plus t2. So that's it. That is the initial velocity in terms of what? In terms of t1 and t2s. Right? Now, if you solve further, that's what we are not going to do it because it takes time, right? So you try to remember some formulas which will save you time in your exam. So in this way only, if you solve this height, at that particular height time is t1 and t2. They are given, right? At what height they are given t1 and t2. So that height you can find out. So by using this formula, half into g into t1 into t2. So just you need to understand this. Remember these two formulas. Mostly question will be asked based on this. Half into g into t1 plus t2. Right? Sometimes this also. At what height the instant times are given. So half into g into t1 into t2. Really? Now, one more. Let's see the second application, my dear students. Second application is so simple. In the last basic section we had already done this. This is the ground. So there is one body is thrown up with some initial velocity u, right, from some height h, okay, from some height h. So there is another body. Imagine this is the body A, okay. So there is another body is B, which is dropped from the height h. So this body will be reaching to the downwards, and this is the body will be reaching to the upwards. After some time t, definitely both the bodies will meet each other. Understand? So one body, imagine this is the one body, alright, and this is the another body. So both the bodies will reach here. So I have just interchanged the colors, so don't get confused. So this is your B and this is your A. So these two bodies will meet each other after some time t. So that's what, let me write here. After some time t, time after which A and B meet. Okay. So we are going to find that. So let's find time after which they meet each other. It is so simple, my dear children. Imagine before meeting A and B, the B is traveled a distance x. When B is traveled a distance x to meet A and A is traveled a distance h minus x, because total value is h. Okay. Now, let's concentrate on B, right? So I'm just writing here. So focus on B, the body B. If you focus on body B, so what I can write by using S is equal to ut plus half at square. So I can say yes, x is equal to half into g into t square, because initial velocity is 0 and half into g into t square. T is the time taken by the body to meet. So imagine it's equation 1. Now let's focus on A, right? So let's focus on A. If you focus on A, what happens? H minus x is equal to, this is S is equal to ut, initial velocity u, t, time taken by the body to meet another body is t, right? So minus half g t square. Okay. So this is my equation 2. Just what you need to do here is, this x value substitute here, just substitute here. So h minus x is equal to ut minus of gt square is x, right? So ut minus x. So h is equal to, see, carefully see, h is equal to ut minus x plus x. This minus x goes to the other side. So cancel. So from here t is equal to what? Is it like h by u? H is what? Distance between the two bodies initially. Understand? So h is distance between the two bodies initially, or height from which the second body is dropped. It's so simple. Okay. Clear? Now, for example, commonly asked the question. So h value they give it as 100 meters and initial velocity value they gave it as 10 meters per second. Simple. If you know h and u, it's easy to find out. After what time the both bodies will meet each other, just you do your h by u value. What is h by u? So given h is 100 meters and u is 10 meters per second and your time is 100 by 10, it's 10 seconds. After 10 seconds they meet each other. It's simple. Clear? Now, one more I just wanted to explain for you now. One more. You know, here, so what I wanted to tell you is, body A will decrease its speed, yes or no? Body A will decrease its speed because it is moving up. Body B will increase its speed because it is coming down. Its value, its speed is increasing, its speed is decreasing. Whatever may be the situation, after some time, both the speeds will be equal. Understand? This speed, imagine 10 meters per second and this is 0. The 0 will be increases to some 5 meters per second. So this 10 also decreases and becomes some 5 meters per second. And there is a possibility of, after some time, the velocities will be equal, right? So I'm writing here. So time after which A and B meet will be h by u. So that's a formula here. So my another formula is time after which both body velocities are same, right? So you know what is this time? So this time you can write it as u by 2g. Just u value. U is what? You should not substitute u is 0 here. U means with what velocity the first body is thrown from the ground. Simultaneously they have thrown. Okay. So one is dropped and the other one is thrown simultaneously. One is dropped, another one is thrown simultaneously. So both the bodies will reach after this time. They meet after this time and they get the same velocities after this time. So u by 2g, if u value you know, you can find out the answer. Okay, clear? So in this way you can solve these questions. Let's have a look at the another application, right? So let's have a look at the third application, my dear children. There is a ground and a tower of height h, a body is thrown up with some initial velocity u here. So what happened? It reached to the maximum height and comes back to the ground. Okay, so comes back to the ground. Imagine the total time taken from here to here is t1. Total time taken from here to there is t. Now, so there is another body here from the same tower. So there is another body which is just thrown downwards with same initial velocity. With same initial velocity, the body is thrown down. The time taken by the body to reach the ground in this case is t2. Okay, ma? Clear? Now, there is a third case. So this is the third case. What happened in this case? This is the third case, my dear students. Same tower of height h, and from here the body is freely falling. So that means it is just dropped. This is thrown downwards, this is dropped, and this is thrown vertically upwards. And you know, this body took a time t3. Alright? After deriving the relation among T1, T2 and T3 will be like T3 is equal to square root T1 into T2. T3 is what? Square root T1 into T2. Right? T1 value and T2 value. So obviously T1 will be greater. Understand? Obviously T1 will be greater than T2. Right? So this T1 will be greater than T2. For example, let's take T1 is for example 9 seconds. Simple. T2 is 4 seconds. What will be T3 then? So your T3 value will be equal to square root 9 into 4, which is square root 36. Root 36 will be 6 seconds. So this will be 6 seconds. Like these questions will be asked. And you may get a doubt how to derive this after deriving. How to derive? So I'll tell you the simple way of deriving this. Right? So derivation will be like this. For example, this body is u. So starting from u. Initial velocity. It will reach to the maximum height where the final velocity will be 0, and again it will come back to the ground, and at this particular instant, so what is the velocity at this point downwards? It's u, because I have told you clearly with what speed you throw the body up, with the same speed it will reach the ground back. So imagine this is the ground. So with what speed you have thrown up, with the same speed it will reach down. So at this point initial velocity u, and at this point final velocity is how much? And you know final velocity. Okay, v square minus u square is equal to 2gh. Use this formula. So like this, after application of all the three equations of motion here, it takes time. So that's the reason we are not doing it. But try to remember the formula. So this is 6 seconds. So T3 is root T1 into T2. You get like this. Right? In this way. Now, so let's focus on this. Let's focus on this, my dear children. Let's focus on this. If you focus here, you get h is equal to half into g into T3 square, right? So easiest way to find height of the tower. Maybe in this case or in this case or in this case, because all the three cases, height of the tower is same. From the same tower, the three events are happening, right? So h is equal to half T3 square. So here h is equal to half into g into T3. T3 is what? So root T1 into T2 whole square. So then you get H is equal to half into G into T1 into T2. Remember this H, height of the tower. Is it a similar equation related to the first case? Look at this. Is it a similar equation related to the first case? H is equal to half GT1 into T2. Here also H is equal to half GT1 into T2. Right? So, fortunately this is same. But two different cases these are. You should not compare with this. Right? Now, here also you can find the initial velocity. With what initial velocity he thrown the body upwards? With what initial velocity he thrown the body downwards? So that initial velocity you can find out. So remember, so you can easily try to recollect from this one. So what is this? So U is equal to half into G into, it is T1 plus T2, right? So you just write it T1 minus T2. That's it. That's the initial velocity with which we are throwing the body up, we are throwing the body down. The same initial velocity. T1 is greater than T2, right? So that's why I wrote T1 is greater than T2 minus T2 I wrote because it is T1 is greater than T2. Okay, so let's 9 and 4. So imagine, take your G value as 10 meters per second square in this case. So let us find, so the answer for this, so U is equal to half into 10 into, so T1 minus T2, it's 9 minus 4, it's 5, right? So this is 2, 5. So initial velocity is 25 meters per second, my dear students. In this way, questions will be asked. Are you ready? Are you ready to solve some questions? And let's solve some questions related to these concepts. Well, my dear students, let's have a look at the numericals here. Number 1. A body is thrown up with a velocity of 29.23 meter per second. Do not get confused by looking at the expression. Do not get afraid even. Distance traveled in last second of the upward motion. What I have told you clearly, if a body is thrown up, you can see, imagine this is the final velocity 0 at maximum height. Distance traveled in the last second is equal to distance traveled in the first second in the downward motion. I told you clearly. So directly, distance traveled in the first second of the downward motion is half G1 square, it's G by 2. G by 2 is 10 by 2, it's 5 meter. If G value is 9.8, it will be 4.9 meter. Understand? Whatever may be the initial velocity is given, directly you can find whenever they ask you to get the distance traveled by the body in the last second, it's a direct answer. Just G by 2. G by 2, it is independent of the U. Okay, just G by 2. You will get it. Let's look at the next question. A stone is dropped from freely, while the other is thrown vertically downward with some initial velocity 2 meters per second from the same point simultaneously. What has happened here? This is the ground. So there is a stone which is dropped from here. So that means, imagine the height is H. Okay. There is another stone which is simultaneously the same time. So another stone which is thrown downwards with some initial velocity. Thrown downwards. The time required by them to have a distance of separation 22 meter. It's so simple. The body which is dropped, slowly it will move. Imagine. After some time t, right? After some time t, so this is the position of the first body, okay? After some time t, position of the second body, look at here. Imagine the first body is travelled S1 distance and the second body is travelled S2 distance. I am assuming that at this difference, S2 minus S1, right? I am assuming that at this distance, so which is 22 meter. After what time it is attained? That's what the question. Understand? Read the question once again. You will understand it 100%. It's so simple. A stone is dropped freely from here, while the other thrown vertically downwards with an initial velocity 2 meters per second. See, this is 2 meters per second. Okay. From the same point simultaneously. The time required by them to have a distance of separation. See, distance of separation between them, which is 22 meters. After what time t, the distance of separation will be 22 meters, right? So, S1, let me find S1. S1 is equal to what from here to here? Half into G into T square. Okay. And what is S2 here? S2. S2 means from here to here. Complete from here to here. See, this is S2. S2 is half into, so S2 means it is thrown downwards with some velocity which is 2 meters per second. So U into T plus half G T square. Okay. So the question is finding S2 minus S1, which is already 22 meters given. So S2 minus S1 is equal to S2, it's 2T plus half GT square minus S1, it's half GT square. Okay, so half GT square cancel. S2 minus S1 is given as 22 meter, which is equal to 2T. From here, T is equal to, can I write it 11 seconds? After 11 seconds, it will happen. After 11 seconds, the distance of separation will be 22 meter. Okay. Clear? Now, one more for your better understanding. One more. So there is a body A which is dropped here. So from the ground, there is another body which is thrown up with some velocity. Imagine from what height it is dropped, it's 200 meters. Right? And it is some 5 meters per second is thrown up, the body B. Question is at what time they meet each other. That's a question given. At what time they meet each other? It is just h by u. H is 200 meters, by u is 5 meters per second, and from here you can get it as 5 into 4, right? It's 40. So 40 seconds. After 40 seconds, both the bodies will meet each other. Okay. Clear? So in this way, questions will be asked. And this is the classwork. You have to do it now, right? So let me explain the classwork question here. A body is projected. Just pause the video and try to do that. Right? Anyway, I'm going to give you the hint now. If you want the hint, you can take it. Otherwise, just pause the video and do it and send me immediately. A body is projected vertically with a velocity u from a tower. It reaches the ground with a velocity nu. The height of the tower is h is equal to u square by 2g into n minus 1. We need to prove this expression. H is equal to u square by 2g into n minus 1. Right? Let me give you a hint. So this is the ground. There is a tower of height h. From here, the body is thrown up with some initial velocity u. So when you throw this, what happens? It reaches to the maximum height and comes back to the ground. Carefully see. This is the maximum height where final velocity is 0. Okay. The question is, it is thrown with the initial velocity u from a tower. It reaches the ground with a velocity nu. Means with nu it is reached. But interesting thing is, it is thrown up with velocity u at the same height. So definitely it will be coming down with the velocity u, right? Told you so many times, if you throw the body from the ground with 20 meters per second, it reaches back to the ground with the same 20 meters per second, my dear students. So then what happens? So this u and u will be same. So here, h is the height of the tower. So let's use a v square minus u square is equal to 2gh. You get this. I need your solution right now. Okay. So look at this expression. A body is thrown up with a velocity u. It reaches the maximum height h, capital H. If the velocity of projection is doubled, then what is the maximum height? It's so simple, right? So just there is single case is involved here. Body is just thrown up. So its maximum height is, so u square by 2g. Maximum height is depending on u. Anyway, g is constant, right? Maximum height is depending on u. So you just take the concept of proportionality and just find out what will be the maximum height reach in this case. Just I need the answer now. Alright, so let's solve 2 or 3 more numericals so that you will be aware of different models, different kinds of questions. Alright, let's have a look at some more numericals. A body is projected with a velocity 50 meters per second. Alright, from here what happened? It is projected with 50 meters per second. Distance traveled by it in the 6th second. What is that? Distance traveled by it in the 6th second. Whenever this kind of questions are asked, first try to identify how much time it will take to reach the maximum height. Okay, how much time it will take to reach the maximum height. So, time taken by it to reach the maximum height, we have the formula, time of ascent, which is u by g. U is 50 by g is 10, it's 5 seconds only. So, 5 seconds it will take to reach the maximum height. 6th second means what? While coming down, right? So, this is the first second of downward motion is the 6th second. Understand? 5 seconds it will take to reach the maximum height. 6th second is downward motion first second. And you know how to find downward motion distance traveled in the first second. So S is equal to half into G into T square. So that is half into G into 1 square. It's 10 by 2. It's 5 meter, my dear students. Okay? Clear? So this is how you should solve the questions. Now, a stone is projected vertically up from the ground with a velocity 40 meters per second. Okay, fine. So, this is the ground. A stone is projected with a velocity of 40 meters per second. What happens? The interval of time between the two instants at which the stone is at a height of 60 meters. So this body will move like this and comes back. So at some particular height, this is what we discussed in the last slide even. At some particular height, time at this point is t1 and at this point is t2. Carefully see. So that means from here to here it is t1 and from here to here it's t2. For your better understanding, imagine this is point A and this is points B and this is point C at the maximum height and that is point D, right? So, T1 is the time taken from origin A to B, okay? And T2 is the time taken from A to B, B to C, C to D. So A to B, B to C, C to D. So the time taken in this case is T2 from here to here. T1 is only from A to B. In this case, I had given you two formulas. What is that? U is equal to half into G into T1 plus T2 and this we have derived even. Okay, and the next I have given you another formula, half into G into T1 T2. Remember this. So the question is, what is the question? The time interval between the two instants. Time interval between the two instants means the question they are asking to find T1 minus T2. T1 minus T2 or T2 minus T1? 100% it's T2 minus T1 because T2 is greater. Alright, so now the question they are asking is T2 minus T1. Okay, this question. For that, try to remember these two expressions. and let's write those two expressions. Why I am writing here is because h is given 60 meters and u is given somewhere 40 meters. So both the values are given, you can substitute this, right? So what is u from here, my dear children? What is u? So u is equal to half into, u is already given, right? It's 40. So 40 is equal to half into g value is 10 into, it's t1 plus t2. Okay. So it is t1 plus t2. So this is 2 5s. 5, 8. So from here, t1 plus t2 is equal to 8. So imagine it's equation 1. Okay, it's equation 1. Now, next, h value is how much given? It's 60. H is equal to half into g into t1 t2. Okay, so this is 2 5s and here 5 12s. So t1 into t2 is 12. So equation 2. Can you solve these two equations? Can you solve these two equations? So you solve these two equations, you get t1 and t2, my dear children. t1 and t2 you get. So your answer will be t2 minus t1. Alright, so your answer is t2 minus t1. So identify the answer and send me now. Just pause your WhatsApp, pause your video and send me your t1 minus t2 value, t2 minus t1 value now. Right? So one thing you should keep in your mind, t2 will be greater than t1. t2 will be greater than t1. Okay, so remember this in your mind. So then you can solve this question. Okay, you may get it out, and most of the students may get a common doubt that how to solve this t1 and t2 now. Just simple. Take t1 from here and substitute in this equation. Take t1 from here, substitute in this equation. You get some quadratic equation and solve this, you get t1 or t2. Then substitute in the other one, you will get it. Alright? Clear? But remember, t2 is greater than t1. Again I am telling you, t2 is greater than t1. Right? t2 is greater than t1. Okay? Clear? Why? Because t2 is what? Time taken from A to B, B to C, C to D. Now the last question, and this is also the class work. There are so many class work questions for you students because I have seen the students asking for the assignment. Right at the end of the chapter, I'll be giving you a minimum of 45 questions on this chapter as your assignment. Right? But now, as you solve some classwork questions and you will understand, along with the 10, anyway the 10 assignment questions will be there. Alright, see here. Simple, there is a body which is projected upwards with an initial velocity v, small v. Initial velocity v. It reached to some height where the maximum velocity is, at the maximum height, the final velocity is 0. That's alright. Now, at some point A, the velocity of the body becomes v by 2. At some point B, the velocity becomes v by 4. At some point C, the velocity becomes v by 8. Alright? Question is, what is the ratio of AB and BC? Right? How to solve? Hint I will give you. Imagine the distance travelled from here to here is x1, and imagine the distance travelled from here to here is x2. So you need to find the ratio of x1 and x2. So x1 is to x2 is how much? That's a question. It's so simple. In between these 2 points apply v square minus u square is equal to 2gh formula, because v and u, u and v we know, right? So what is the formula you need to apply? So v square minus u square is equal to 2gh formula you apply. And my dear students, remember and do not forget this g. G is negative because the body is moving up. So g is negative. Okay. Alright, so you get me this answer also now. And sometimes the questions can be asked in this way also. So, ratio of AB to AC. or ratio of BC to AC, or ratio of BC to AB, or this one only almost. Alright? Like these questions will be asked. Clear? Okay. All the very best for your assignment for today. Just take some breathing time for your preparation as well as writing down the notes, and your assignment will be there now. All the very best.